Hi, I'm Ben Lawrence. I'm a freshman and a computer science major,
And I'm Lainey. I'm a senior in environmental engineering.
and we're the textbook sub-team within Aguacara. And our main mission so this semester has been focused on improving accessibility within the Aguacara textbook. So just to give you a short outline of our presentation, first we're going to talk about our sub-team's goals, both the previous semester, how that kind of led into what we worked on this semester, and then from what we accomplished this past semester, our goals for the future of the sub-team, kind of offering a chronological perspective in that regard. Then we'll move on to coding within the textbook and how we worked with Google Colab and had to debug certain areas of Python code in order to properly allow for interactivity within the textbook. And then finally, how we implemented that within the actual Aguacara textbook, like the HTML version, before talking about our future plans. So now moving on to our textbook sub-team goals, we were primarily focused on improving accessibility within the Aguacara textbook in terms of making the Python snippets that are currently there more interactive, allowing for the user to fully take advantage of the coding resources within the Aguacara textbook. And in addition, we worked on the Google Colab and Python portions of the textbook in parallel with Aguacara Reach, as they were also modifying it this past semester.
The textbook sub-team is a relatively new sub-team that started this year to address the functionality of the Aguacara textbook. So to all of the research sub-teams, have you ever used the Aguacara textbook? The answer is probably no. But it is a really useful tool. So you can use it to understand the concepts behind Aguacara treatment processes, including like the equations and the processes and the laws that govern filtration, sedimentation, and the other processes of water treatment. You can use it to have a better understanding of Aguacara filtration and water treatment technology. It is the textbook for the Sustainable Safe Water on Tap course, which is supposedly going to be offered in the next coming semesters at OSU. And then it also has a lot of Python examples that you can follow for your drinking water research, and also to better understand the use of the Aguacara package. So our goal as the textbook sub-team is to make the textbook more useful for students and other members of Aguacara. So here's our timeline over this and last semester and into the future. So last semester, we focused on translating the entirety of the textbook into Spanish using a automated translation software tool called POEdit. And so we were kind of finishing that up at the beginning of the semester, and we've since moved on. So then at the end of the semester, or throughout and at the end of the semester, we have been creating an entire GitHub repository that is full of Collab files that correspond to the Python code that is available within the textbook. And then the future of the team. So as Ben mentioned a moment ago, Aguacara Reach is editing the textbook content-wise, and we are expecting them to really change the format and the information that is available in the textbook now. And so we anticipate that that is going to affect the goals in the future of this sub-team.
So transitioning back into what our sub-team has been working on this semester, as you can see, this is currently the state of Python code within the Aguacara textbook. You can see the snippet in green and how it's not really allowing for any interaction in terms of the user being able to work with it directly within the textbook, as it would require someone to copy paste all of the code and then run it within their own programming environment. And we felt like that created a barrier in terms of not allowing as many users to be able to actually run the equations and formulas that the Aguacara textbook describes throughout. And that this kind of segues into using Google Colab and why we wanted a more seamless way for when to utilize the constants and functions within Python. And the reason why we chose Google Colab is that it's a software tool that allows one to write and execute Python code within a web page on one's browser. And as you can see from the attached image, the Collab allows for multiple blocks of Python code to be run within HTML files, which is what the Agriculture textbook is within. And the fact that we can work on this within Google Drive allowed the textbook subteam as a whole to be able to work on it with little barriers in between. And another advantage with Google Collab is playground mode, which allows for us to be able to edit it very easily without affecting the final state of the program. And additionally, for the user, they're able to change variable values when using the Collab files in the textbook without making any drastic changes to the overall setup.
So to get the content that's within the textbook into Google Colab, we split up the textbook between the two of us, and we went through the whole thing, and we copied each code snippet into Colab, and we took advantage of Colab's ability to create sections and subsections to create a mirror of the textbook, where each file was a chapter, and then we sectioned and subsectioned the file the same way that the textbook is. And so we also made sure to hyperlink back to the textbook. So if you're working within the Collab file, you can very quickly go back to the textbook and refer to the equations behind the Python code and the conceptual information that's around whatever problem you're working in. So we spent a significant amount of time having to fix and debug the code. So some of the code is actually just not functional. It's not meant to be functional, and that's actually acknowledged within the textbook that it doesn't work. So those pieces we very much ignored. But there were also a lot of changes to the Agua Clara package made since the code in the textbook was written. So it's just a few years. And mainly we saw deprecations of functions and some constants, as well as some unit conversion issues as there were changes in kind of the way the package handles units. So we went through every code block that we created, we tried to run it, and any issues that came up, we fixed them to the best of our ability.
So kind of continuing with the theme of debugging, some of the most notable errors that we faced when working with the textbook were, as shown above, an error within unit inconsistency, and that oftentimes we were adding two different variables that had two different units. So this required us to have to look at the formulas written out within the textbook to be able to see where the Python code itself went wrong in terms of unit dimension analysis. And then to the bottom left within the slide, another common error we ran into was when a certain function was deprecated or just no longer existed within the Agriculture package, or it had been moved to another subsection within the package itself. So for this error, if the function no longer existed, we'd either take the code out or replace a certain method with an alternative that had recently been added onto the package. And if a certain method was moved to a different area within the Agriculture package, we would then go to GitHub and try and look through the different subsections to find out where exactly the method had been moved. And so this kind of moves into now working with GIST and actually being able to implement our work within the textbook itself. So GIST essentially are snippets of code from a Git repository that allow for excerpts of programs to be shared on multiple modems, which in our case was the HTML files and within the textbook. And so we were able to use GIST to store Collab files with runnable code within the textbook documents themselves, and allowing the user to then run the Collab files within Google Collab itself. As you can see, there's an option to open said file within Collab. So this still allowed a user to use all the functionality that Google Collab itself offers while accessing it through HTML. And so the steps we used to actually get the GIST to work were first saving our Collab files as a GIST, making them public within our repository, and then copying the embed code from the GIST into the HTML files for the different chapters in order to allow it to appear.
So currently we have not completely implemented GISTs as a means of viewing textbook code within the textbook. We have only basically done a single example as kind of a demo to make sure that this process worked properly. So we're still undecided about whether or not we're going to proceed with putting GISTs throughout the textbook as the means of viewing code within the textbook. But the rest of the Collab is done. And then the other future work that is happening is related to Agua Clara Reach. Again, as we've mentioned before, Agua Clara Reach is planning on really changing the content of the textbook, and that work is going to be happening primarily over the summer. And we're anticipating that the work that they do is really going to change the direction of the textbook subteam. So here's our appendix. There's a couple of sources that we used for how to get Collab working in an HTML file using GISTs, as well as a link to the textbook itself. So this is our presentation. Thank you for listening. If you have any questions or comments or are interested in the textbook itself, please feel free to contact Ben or I with any inquiries.